Hi y'all, we're going to do notes over hyperbolas today. A hyperbola is another conic section. It's very similar to the ellipse. It has a center at HK. You can see that in the equation here and here. In the equation, it'll also be set equal to 1. You'll have an x value squared and a y value squared. The main difference between a hyperbola and an ellipse, though, is that you'll have a minus sign separating those two squared terms. Okay, once you know that you have a hyperbola, you need to know, is it horizontal, so does it open left or right, or is it vertical, so does it open up or down? It's easy to see from the picture. From the equation, though, if it's going to open left or right, the x value will be squared. If it's going to open up or down, the y value will be squared. And the a squared value will always go with the positive variable. All right, once you know if it's horizontal or vertical, you need to determine the vertices. And those will always be a units away from the center. So if it's a horizontal hyperbola, you'll take that center and you're going to add or subtract the a value to the x value of the center if it's a horizontal one. If it's a vertical one, the y value is going to change, so you'll add or subtract that a value to the y value of the center. That will give you the two ordered pairs for the vertices. Your vertices are here and here on the horizontal, and they're here and here on the vertical. All right, after you get the vertices, you've got to do the foci. They're going to be c units away from the center, and you'll get that c value by doing c squared equals a squared plus b squared. And then you'll do the same thing to get those ordered pairs, either adding it to the x or the y value of the center. After you get your vertices and your foci, you got to think about your asymptotes. And these are the equations for those asymptotes. I'll kind of show you in the picture where the asymptotes are. They're imaginary lines that those hyperbolas are approaching. Okay, so they are literally lines. And so think about the equation of a line, y equals mx plus b. We're using the center to help us get those equations. We have y minus k and x minus h. You've got if you'll notice here, you've got a positive slope and a negative slope. And so we've got a positive slope and a negative slope. And the way we get that slope, think about slope. Slope is change in y over change in x. If you've got a hyperbola that opens left or right, like up here in your equation, the b value is underneath the y and the a value is underneath the x. And that's why we have b over a in our equation. If you've got a hyperbola that opens up or down, up here in your equation, the a value is underneath the y and the b value is underneath the x, and that's why our slope is a over b. And then remember, you've got to do a positive and a negative. All right, let's do an example of these. So I think that'll help us. Okay, so here's an example. If you'll notice here, our x value is the one that's squared, so that tells me that this one is going to be horizontal. It's going to open left and right. The center is at 2, negative 3. My a value will always be underneath the positive terms, so it's going to be 3, and b will be 4. To get those vertices, you take your center, 2, negative 3, and you're going to add or subtract the a value to the x since it's horizontal. So it'll be negative 1, negative 3, and 5, negative 3. To get your foci, you've got to figure out your c value, so you'll do that by doing c squared equals a squared plus b squared. So we'll do c squared equals 3 squared plus 4 squared, which is going to be a c value of 5. And you'll add that c value to the center, so you'll take 2, negative 3, and you'll add and subtract 5 to the x value of the center. So it'll be negative 3, and 7, negative 3. And then you've got to do your asymptote equations. You use the center to help you, so it'll be y plus 3 equals, you'll have a positive and a negative slope for each of those. To get the slope, remember we do change in y over change in x. So the b value is underneath the y, so we're going to do 4 over 3. And then we'll have that x minus 2. All right, let's graph this. So we've got a center point at 2, negative 3. Vertices at negative 1, negative 3, and 5, negative 3. Okay, and I'm not going to graph the foci yet. I'm going to draw like an imaginary box around this center using my a and b value. So the b is underneath the y, so I'm going to go up 1, 2, 3, 4, kind of make a little dash there, and I'm going to go below the center 1, 2, 3, 4. I've already done the a value by when I drew those vertices. And I'm going to draw kind of a little imaginary box around that center using those a and b values. Okay, so that'll make it a little easier for me to draw the asymptotes. I'm going to use actual ones. I'm going to draw the diagonals of that box, and that will be the asymptotes. And then I don't really have to use the equations that I wrote up there. Okay, those are my asymptotes. That's what the hyperbola is going to be approaching. So I'm going to go back to my vertices that were right here, and we're going to just draw the hyperbola. The hyperbola just has to approach those two asymptotes. I didn't graph my foci, so let me do that real quick. We have one here at 7, -3, and one over here at -3, -3. All right, so that's the first one graphed. Let's do the second one. I'm going to clear that one off. Well, I'll leave it. I think we've got enough room. So this time, the positive term is the y, so that tells me it's vertical. The center is at -2, -5. It's easy to get those mixed up. Remember, the x value of your center is with the x, and the y value of your center is with the y. Because it's opening up and down this time, when you do your vertices, your a value is with the positive term, so it's 5. The b value is with the other one, so it's 2. So you're going to take that 5, and this time you're going to add it to the y value of your center. So to get your vertices, you're going to do the -2, -5, and you're going to add and subtract 5 to the y value. So you'll get -2, 0, and -2, -10. To get your c value, you'll do c squared equals a squared plus b squared. So you'll do 5 squared plus 2 squared, which gives you a c of square root of 29. All right, so again, that number is going to be added and subtracted to the y value of your center. So I'm just going to write it like this: -2 and -5 plus or minus the square root of 29. I don't want to actually get that value. I kind of know where it is, but I'm not going to get the decimal value of that yet. Okay, so my asymptotes, I'm going to use that center, so y plus 5 equals plus or minus. Using change in y over change in x, the change in y value will go on top. That'll be 5 over 2, and then it'll be x plus 2. So that's the equation of my asymptotes. All right, let's graph this. So -2, -5. If I can graph it, there it is. And then vertices at -2, 0, and -2, -10. All right, and so that's given me the a value from the center. I'm going to do the b value on either side of that center, and then just kind of draw an imaginary box. All right, so let's draw the asymptotes. Usually those are dashed lines. This is just easier on here for me. I hope that's okay. And then I'm going to use these vertices that we have right here and draw the hyperbola. All right. I'm not going to worry about graphing that. This would, well, I could. The foci is at -2 and then -5 plus or minus the square root of 29. Square root of 29 is a little over 5. So it'll just be a little past here and a little past here. That's not a big deal if you don't graph it. The main point is to have the asymptotes and then the actual hyperbola graphed with the vertex right there. Okay, so let's switch pages.